Hello everyone, I am Dr. Krishnasree, working as Associate Professor in the Department of ECE at VNR VJEC. Now I would like to explain about power amplifier, that too introduction to power amplifier. Let us see what is power amplifier and how it is different from voltage amplifier. So first we will differentiate, define and then see what are the types of power amplifiers and so on. Today I am covering the contents. First, I'll define what is an amplifier and how the amplifiers are classified. It contains a power amplifier as one of the classification of amplifier. Then what is the need of power amplifiers when compared to other normal amplifiers? Then what are the applications? Then what is the difference between voltage amplifiers and power amplifiers? So these are all the contents which covers the introduction to power amplifiers. Let us see. First, define what is an amplifier. Amplifier is a circuit which is indicated with a symbol of a forward triangle. It takes an input signal which is any sinusoidal or continuous time signal with a frequency and an amplitude. If you apply this signal to an amplifier, it amplifies without changing its frequency, only increases the amplitude. Then it is known as an amplifier. Amplifiers based on different parameters like what kind of parameter we are increasing or we are changing. So there are different types of amplifiers are available in the literature. So basically amplifier will take an input signal which is a continuous time and then it provides some amplification without changing its frequency and it should not introduce any distortion. So let us see the classification of amplifiers based on various points, various parameters, how it goes. Now if you see here, the amplifiers are the basic amplifiers. Then power amplifier also will come one of the classification of amplifiers. Now we can see there are many parameters. Maybe number 1, how the active device is used, and number 2, what are the configurations of the devices, and number 3, what is the load will be used, number 4, what are the Q points, where the Q point is located, then number of stages, then how many types of amplifiers based on the parameter. Next classification comes based on the frequency response. Next parameter will be taken as bandwidth and the classification will be done based on the bandwidth of the signals we are applying. Finally, based on the coupling. So now let us take the first class which is taken as active device based on active device classification. In electronics, basically there are 2 devices which are known as bipolar junction transistor, field effect transistor. The amplifiers which are constructed using these 2 devices, there are BJT amplifiers, there are FET amplifiers. Number 2, based on the configuration, the amplifiers are divided into either common emitter by using a BJT or common source by using a FET. This is one type. Next classification is common base, BJT based, common gate, FET based. Then common collector and common drain based on FET based. So how the configuration of the device we are going to use in construction of amplifiers, the amplifiers are divided into these 3 classifications. Next, based on the load. Basically a load normally we can be using as a resistor, as a load resistor. But sometimes different loads will be used. If the load is a tuned circuit, then we known as a tuned amplifiers. Other than the tuned circuit, then all other amplifiers we can classify as untuned amplifiers. So all the remaining amplifiers which comes under this category only. Then coming to the 4th one is Q point. Generally, amplifiers will be working based on the Q points where it is located. Suppose if the Q point is in the active region, it is known as class A. If the Q point is in the cutoff, it is known as class B. If the Q point is between middle of the load line and the cutoff, we call it as in class AB. Then below the cutoff, we call it as class C. Now we will see this Q point based power amplifier classification. Later, based on the Q point, these are divided, and this is the one which we are going to concentrate in this power amplifiers. Next, coming to the number of stages. If a stage, only one stage will be used, it is known as single stage amplifier. This single stage means any amplifier so far whatever we have taken in the previous classes, if contains only one stage, we call it as a single stage amplifier. But similar stages, more than one is used, then we call it as a multi-stage amplifiers. Multi-stages can be more than one. It can be 2, 3, 4 and so on up to n stages. Then the next classification is based on what type of signal have been used for amplification. Suppose if the voltage wise, if an input signal is given, then it is amplified only in terms of its amplitude, then we call it as a voltage amplifier. Next classification is power. Here, the parameters, both voltage and currents have been considered, then combinedly it enhances the power. Then we call it as a power amplifier. Next, based on the frequency response, that is, what is the range of frequencies we are taking for the signal to be amplified. If it is in a audio frequency range, we call them as audio frequency amplifiers. Intermediate frequency. Basically, this IF is used in the communication applications. So, for FM radio, IF range will be 1. For TV, IF range will be different. So, based on the IF ranges defined for our application, the amplifiers have been named after audio frequency, intermediate frequency, radio frequency, and microwave frequency. So, basically it decides what is the range of frequencies. For the signal we are given as an input signal, it is decided as frequency response based amplification. So, these are AF, IF, RF and microwave. Other than more than RF, all the frequency ranges we call it as a microwave frequencies, or it is in the range of gigahertz. Next parameter is bandwidth. If the signal bandwidth is having a narrow band, that is maybe order of kilohertz, we call them as narrow band signals, and amplifiers we call them as narrow band amplifiers. Next, if you take a wide band amplifiers, the range of frequencies is ranging from more than kilohertz and then megahertz, then we call them as wide band amplifiers. Finally, the coupling. Last scheme coupling will applied only for the multi-stage amplifiers. If you are using more than one stage, then from one stage to another stage, how these two stages have been coupled together is known as the coupling schemes. There are basically 3 different coupling schemes. One is RC coupling, inductive coupling, transformer coupling, and without anything we call them as direct coupling. So, based on different parameters, this classification of amplifiers, there will be different amplifiers are available. And if you take the power amplifiers, then this one comes into this type of output, what kind of output we are taking. And as a continuation, these power amplifiers, based on the Q point, we have been divided into again some more classifications. So, this is the classification of amplifier will go like this. Then we will move on to why we need power amplifiers. So, generally, before the power amplifiers, we are using normal amplification. This, according to the definition of normal amplification, if you take a input signal, without changing its frequency, we are getting amplified only in terms of the amplitude. So, if you look at the frequency, if whatever the frequency you are considering, the same frequency will be applied at the output also. So, this kind of amplifications we call them as normal amplifiers or voltage amplifiers, because these are being amplifying only the voltage of signal or amplitude of the signal. If you look at power amplifiers, it is not the normal voltage amplifiers, but it is little bit different from this one. So, I am taking one application. So, suppose if you take, I am speaking through a microphone and it is delivered in terms of a speaker, loudspeaker. Then how this signal which is created by using a microphone. Maybe some person is talking over this microphone. Okay, first we want it amplified, and the volume of the amplified signal will be such a level, so it should be reached to over longer distances, or it should reach to a over large audience kind of thing. So what are the different stages will be there? Suppose if you take the first stage, it contains, normally it amplifies in terms of the voltage. If you want more gain, then I have to add one more stage. We call it as an intermediate stage. So these first two stages will amplify the signal generated from this microphone. Normally this is called as a transducer, which converts our physical speech into electrical speech. So normally the voltage, which is order of millivolts or few less than 1 volt, will be generated from a human. Then it is amplified. Some signal I am taking, some sinusoidal signal, it is amplified with the same frequency, So this millivolt signal, after 2 stages, it becomes intermediate stage 2. This is also voltage amplifier. So 3 stages I am using. So it is enhancing its amplitude with a different voltage levels. So if you take a signal in millivolts level, it is becoming almost volts level. So now your amplifier should be able to amplify this voltage, also including some current amplification, so that its power will be amplified. That is, it can create a larger volumes of speech or larger amounts of speech or with more volume through a loudspeaker. So if you take the first one is, first stage is voltage amplifier, intermediate stage is also voltage amplifier. So I have extended for further gain. I have used 3 stages for amplifying in terms of voltage, and finally, final stage, it should also add the current amplification. So whenever you want a signal should be amplified with an enormous amounts of power, then we require power amplifier at the last stage. So if you take any application where you require larger amounts of signal should be amplified, like music systems, DJ systems or anything. So later I'll cover what are the applications. So we require at the last stage of any amplifier should be a power amplifier. So this is the need. So what is the need? If your signal want to be amplified, you have to add power to it. So that's why a power amplifier should be used at the end of your any amplifier. Then it becomes a power amplifier, totally we call it as. Next, after the power amplifier, so we have voltage amplifier and power amplifier. Power amplifier, again we have to classify into various amplifiers. So here, power amplifier, as the definition, it amplifies both voltage and current. Then how these power amplifiers will be divided further into further classifications, then the point to be noted is based on operating point or Q point. It should be selected. Suppose if the Q point is in active region, so if you want to see the Q point, means it is load line which is taken a graph VCE versus IC of any transistor. So any operating point we have to select on this load line. This is known as a load line. Suppose if there are 3 regions can be divided on the load line. This is known as cutoff. Then the top one is known as saturation, and all the remaining portion we call it as active. So if the Q point is in the middle of saturation and cutoff, it is known as active region. If the Q point is in active region, we classify it as class A. If it is on Q point, we classify it as class B. Below cutoff, if the Q point is there, then it is known as class C. Between active region and cutoff region, then we call it as a class AB. And depending on Q point, which is not operated on the load line, but it is operated on a switching mode, we call it as class D. So these are basic power amplifiers which have been divided based on its Q point or operating point where it is located. This is the classification of power amplification. Then we'll come to applications of power amplifiers. So first application, it is very general and very generic and very popular, which is known as public address system. So any person, they want to address a public like this, so which are having more public, and directly the speaker speaks through a microphone. So maybe for the first front end of the people it may reach, but to reach the larger at the end of the region, so the power generated by a human being is not sufficient. So we have to take a system known as mic system. Generally we call it as in normal words, but it is a public address system where a power amplifier will be a important source to increase the volume or power of the speech, which has to be reaching the people at the end of the public or at the last outer end of the public. So all public meetings, whatever we are using the systems, will contain power amplifier as one of the important topic or block inside, as I have shown you in the first initial slide. Then in the radios, maybe it can be FM radios nowadays or AM radios in the olden days. Some transmission which are coming from a normal broadcasting. So this is a receiver. Suppose if you take this is an FM radio in olden days. Nowadays it is available in the mobiles itself. So if you want to listen through a headphones, normal power is required. But if you want to listen through a speakers like this, then it has to generate higher amounts of powers where we require a power amplifier inside. Then TV receivers. You can see this is a TV receiver. Whenever a powerful song or powerful scene is coming in the TV, we would like to enjoy that one by increasing the volume. So how this volume can be generated? By generating more or power or powerful song from the TV receiver, then only it is able to come out of the TV receiver to the ambience with a larger amounts of powers. Then servo motor controls. If you take the industrial purpose, motors will be controlled by using some small control signals, but those control signals does not have power to control a larger amount of motors or a bigger motors like servo motors, stepper motors kind of thing. So actually this is a servo motor control where it is controlling its position, controlling its speed, controlling its current, finally it controls its power. So to drive larger loads like the servo motors, stepper motors in industries, we require power amplifiers inside the amplification section. So there are different feedback loops and so on. So how the servo motor speed can be controlled and so on. But as we are interested, power stage will be a important stage inside motor controls, especially servo motors will be used in the industries normally. And if you see the entertainment, it's a music players. So maybe I can divide into entertainment, 2 and 3 will be communication applications, the 4 is in the industrial application, 5 is also an entertainment application. You can see here it is the olden days gramophone records, okay. Then middle days, some cassette players or nowadays music systems and power DJ systems kind of things. So all these are used for entertainment purpose where some kind of input signal, it can be a music, it can be a cinema, video or anything, it will be amplified and then it is transmitted into the ambience with a larger amount of powers where there will be power controls and so on. So in one sentence I can conclude application of power amplifiers is needed wherever you want the signals has to be amplified with a enormous amounts of power, enormous amounts of volumes required. So these are the applications of amplifiers. Then lastly, other than power amplifiers, there is an voltage amplifier. This classification I can give you how these are different from the normal amplifiers. Other than power amplifiers, all the amplifiers I'm just putting into a common or wide range voltage amplifiers. So there are basically some parameters considering. First, basic function. Basic function, voltage amplifiers provide only voltage gain will be provided, that is the signal is amplified in terms of its voltage. But in the power, it requires higher power gain, that is it have to provide voltage gain as well as current gain. Then input, as I have told, small order of millivolts signals is taken as a small signal, and then after applying to too many stages, it becomes order of volts. So then the signal will become larger in size. So basically, if the input is small signal, it is applied to voltage amplifiers. Then signal is applied to the power amplifiers will be order of voltage amplifiers. That's why the other name of power amplifiers is also known as large signal amplifiers. Then one analysis technique is popular for electronics analysis, electronic circuit analysis, which is known as H parameter analysis. It is applicable for voltage amplifiers, but it's not applicable for power amplifiers, because this H parameter analysis is a small signal amplifier analysis technique. Then coming to the beta. Beta is the DC current gain. So it is larger for voltage amplifiers, order of some 300 and so on, but it is very low value for power amplifiers. Then coming to the transistor, what type of transistor is used for voltage amplifiers? With low power rating for the voltage amplifiers, transistor with high power rating for the power amplifiers. Then there is one special component which is known as a heat sink, because this power amplifiers is dealing with the larger amount of powers. Similarly, the voltage, the heat generated also will be large. So that heat has to be taken out of the circuit. It's known as sinks. Heat sinks is a special type of device which is used for voltage amplifiers. It's required. It's not required for the voltage amplifiers. Then the coupling. Normally the voltage amplifiers required couplings like RC coupling and so on, direct coupling. But here, for this power amplifiers, we prefer normally transformer coupling, which cannot be preferred for the voltage amplifiers. Then type of input signals. So it amplifies both audio frequency signals as well as radio frequency. But if you come to the power amplifiers, it amplifies only the audio frequency signals, because these are meant for or developed for audio signals like music or speech kind of thing. So these are normally used for audio frequency range. That's why other name of power amplifiers is also known as audio amplifiers. Then the distortion. Distortion means when you are operating or amplifying in terms of voltage or in terms of power, the input signal is not going to be available in the same form, then we call it as a distorted waveform. So in normal voltage amplifiers, the voltage will be, it should be preserved its shape. So distortion cannot be available. But here the shape is not preserved. So there is a distortion is available in the power amplifiers. So if you look at this one overall, power amplifiers, the input signals is order of volts, and it cannot amplify input signal as it is because it provides distortion. Normally transformer coupling will be used, so they are larger in size, and transistors with higher power ratings will be used. So heat is generated will be usually normal. So we have to use the heat sinks. Then it provides larger amounts of the power. So it can be used wherever you want to amplify your signals from a small volumes into a larger volumes. So these are the advantages of power amplifiers, and disadvantages altogether have been compared with normal voltage amplifiers. So this is a small introduction about the power amplifiers. In the next video, I'll explain the different power amplifiers and how they are operating, how their frequency, what are the frequencies they are used, and what are the efficiencies they can convert from normal signals into powerful signals. I'll explain in the next video. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.